Hey there, Python trainer Reuven Lerner here, and today I want to dig into how data is stored behind the scenes in Pandas, how we can affect that, and also some weirdness in the way that it's implemented that the documentation might lead you astray when you look at it. So let's look at this first of all. Import pandas as PD, and then I'm going to load up one of my favorite sample data sets. It's just 10,000 rides from New York City taxis about, I guess, 10 years ago at this point. So I say df equals PD read CSV of taxi.csv, and it loads in successfully. Now CSV is, of course, a text file format, and Pandas stores things as binary data. But how does it store as binary data? Right? And when I say binary data, it's not storing it as text, right? It's actually storing it as integers and as floats. But we don't want Python integers and we don't want Python floats because those are going to be really big. They're going to take up lots of memory and thus they're going to slow down any computations that we want to do. So for this reason, Pandas has long been what I think of as a wrapper around NumPy. NumPy, you can think of as like a Python wrapper around some C data structures, where C is really fast and really efficient, but it's kind of hard to work with. And so if you use NumPy, then you get the benefits of both worlds. You get to live in Python, but you get the benefits of the speed and efficiency of C data structures. Pandas then makes it even better, where Pandas lets us use NumPy with even less trouble. So if I look at df.head here to look at the top of my data frame that I just created from reading the CSV, so we see some strings and we see some date times. We're going to ignore those for now, but we see integers and we see floats. If I say df.dtypes, we see that these are int64 and float64. And normally in the Python world, we don't think about 64-bit integers and 64-bit floats. We just think of integers and floats. But that's the whole thing. When we're working with Pandas and thus with NumPy, we have to think in those terms because at the end of the day, it's really a C data structure. All right, and so we know that each integer is going to be 64 bits. At least here, we know that each float is going to be 64 bits. End of story. Well, sort of end of story, because it turns out that NumPy, while it's amazing and great in many, many ways, it has some flaws, at least when we are trying to do data analysis. And one of the problems is, let's say I have an integer column, right? Let's say passenger count's integer column. Let's say that we don't have data for passenger count for row 0, right? We just don't have the data. I don't want to say 0 passengers because that would lead people astray. I don't want to say like -1. That's even worse. So what I can do is I can say is df.lock of 0, passenger count. And we'll just say that is, well, I have to load it up, import numpy as np. I'll say np nan. And nan means not a number. And actually, NumPy is Pandas is totally okay with me doing this. And I now say df of head, and we see that we have a nan value there. But if you look really carefully, you will see that the other values are now 1.0 and not 1. And that's because whereas before passenger count was an int64, now if I say df.dtypes, now it is a float64. And that's because our dtype of int64 cannot handle a float value. It just can't. And so Pandas, when faced with this, says, well, I guess I'll just turn all these integers into floats, and by making them floats, then I can have nan there, and then everything will be fine. So this is kind of annoying, right? I don't necessarily want that column to be set to be floats, but I'm now stuck, right? Either I have integers and no nans, or I have floats and I do have nans. And that's because, right, so the int64 dtype in NumPy is not nullable. So how can I deal with this? Well, I can use Pandas extension types. And Pandas extension types basically are wrappers around the built-in, or not the built-in, but the NumPy types. And they allow us to use something known as pd.na. And pd.na is sort of the Pandas replacement for NumPy's nan. So if I want to, then I can do something like this. I can say df equals pd read CSV of taxi.csv. And then I'm going to do this. I'm going to say dtype backend equals NumPy nullable. So I read this in, everything seems fine. And now I say df.head. Let's take a look at it. Looks pretty good to me. I say df.dtypes. And now look at this, the dtypes are different. It is still int64, but there's a capital I int64. And still float 64, but the capital F 64, float 64, and strings now say string Python. It's very obvious that this is a string and that it's a string being stored in Python land as opposed to object, which is what we would have gotten before. And so now if I say df.lock0, passenger count equals pd.na, well, now if I say df.head, we're going to see that I have an NA value there, but these remain ones, these remain floats. And that's because the extension types are nullable. We can use pd.na along with the integers. We can do that with floats as well. And well, floats are not great shakes, but we can do it with strings as well. If I want to, I can say here df.lock of 0 and tpep pickup datetime. And yes, this would normally be a datetime value, but no, I did not parse it as such, equals pd.na. And so now if I do df.head, we're going to see this is na and it does not change the fact that we still have strings here, Python strings, because pd.na does not interfere with that. This is fantastic. But we're still using the NumPy types. And one of the flaws with NumPy types is indeed the nullability, or lack thereof. The other problem is that they're just not that fast at doing certain kinds of analysis. They're really fast at storage, but they're not necessarily fast at the sorts of things we want to do in Pandas. And so what I can do is I can say df equals pd read CSV. Let's read it a third time, tax.csv. I'm going to say here dtype backend equals PyArrow. And now we're going to be using the PyArrow library, which is a Python set of bindings for the arrow data structures behind the scenes. And now if I say df.dtypes, look at this. First of all, right, we can see that everything is now PyArrow. It says that in the dtypes. It's an int64, but in PyArrow. It's a string in PyArrow, meaning we are no longer using Python strings. No longer in NumPy are we going to have a pointer to a Python string. Rather, we're just going to store it right there in PyArrow. That makes it faster, and PyArrow does all sorts of compression and all sorts of other neat tricks to basically ensure that it is as fast and as small as possible. And this is compatible with pd.na. So if I now say, once again, df.lock of 0 and passenger count equals pd.na, now if I do a df head, we're going to see the na there. It does not get turned into float, and that's great. So this is fine. This means that we basically have three ways to store data in Pandas. The default way, which is NumPy. The extension types, which we can call NumPy nullable, or PyArrow. PyArrow is still a little new, a little experimental, and most people are not going to be setting the dtype backend and probably should not be without checking thinking first. So where's the confusion? Where's the problem? Well, first of all, it's just confusing because now you have three options that you have to choose from. And yes, most people most of the time should now still be using the regular old default. But let's take a look at the documentation of read CSV. And if I go here to read CSV, let's make it a little bigger for you. You will see that indeed we have the dtype backend, no default. Now you would think that this means that there is indeed no default value. But then if I go down to the larger documentation of dtype backend in this page, it says here, oh, well, we have NumPy nullable and PyArrow as potential values, and the default is NumPy nullable. Wait a second, does that mean then that if I don't specify dtype backend, I'm getting NumPy nullable? No, it does not. If you don't specify dtype backend, as we have just seen, you get plain old NumPy. Well, wait, can I now load up, can I say df equals pd read CSV of taxi CSV, and I can say then dtype backend equals NumPy? And the answer is no, I cannot do that. Even though that is the standard, even though that is the default, it says dtype backend and NumPy is invalid, only NumPy nullable and PyArrow are allowed. So let me just lay this out for you. There are three different storage options: NumPy, NumPy nullable, and PyArrow. All three exist. We know this. We have seen this. Documented here, it says that we can choose, though, from only two of them, NumPy nullable and PyArrow, and NumPy nullable is the default. But if we look at the top of the documentation, it says, no, actually, it's no default. What the heck is going on here? And this was raised by someone in one of my online classes at the Learner Python platform during our office hours, and I was super confused. So this is what I've managed to find out, understand from reading through documentation and some issues in GitHub from the Pandas project. Number one, they don't want people using dtype backend unless they really know what they're doing, right? You just should not be messing with it. And as such, they want to basically say to people, don't use dtype backend, just use the default until things stabilize and you're definitely good there. You don't want to be messing around with extension types or with PyArrow if you don't know what you're doing. So the default is really NumPy. However, the way that they implement the default is using this odd object called, I think it's no default. I think that's what they actually called it here. Yeah, no default, which is a special object that they defined inside of Pandas, which then allows them to say, well, there's no default, meaning we will take the default of NumPy, but that when you pass this keyword argument, we are going to limit the values that you can use. And they say that they are doing that on purpose because they don't want to give the people the illusion that they should be passing dtype backend equals NumPy. And they don't want people invoking this unless they're really experts and they know what they're doing with using dtype backend. Bottom line. The documentation is, as far as I'm concerned, kind of misleading. I understand they're trying to help people, but it's just like really confusing to get what seems like two different messages in two parts of the same documentation document. Most people, most of the time, don't ever use dtype backend. If you do use it though, you're only going to be using it to change from the default dtype backend to either use extension types, that is dtype nullable, or PyArrow. You cannot use it to explicitly say, I want the regular old, not nullable, non-nullable non-nullable NumPy values. Phew. All right, I hope that this was useful and interesting. Let me know what other questions you have about Python and Pandas, and I will answer them here. Thanks a lot for watching. Don't forget to like and subscribe, and I will be back soon with lots more about Python and Pandas.